Okay, it's time to get started, so let's get moving. So I am going to be honest, I don't remember what was the last thing we was doing, but I have an idea of what I want to do first. I don't plan to be too talkative today, because I want to focus on this to move on. But basically, what we are currently doing is running a test room, which is this room that we downloaded from nesdev.org, and this test prints the output of what is our CPU processing and compares this with what is expected to be printing. And this is kind of interesting, but I want to improve this logging to be more useful. Yep. So let's start with that. So I want to avoid printing if the stuff matches. I want to be more visual with what is different, and so on and so forth. So let's start with that, I guess. So okay, let's start doing this. Let's reduce the noise that we are getting, because once the noise is reduced, we can remove this strain, right? So first of all, I want a buffer of what has been the last traces. So let's create by creating a class for the trace. Class trace var log of type string var so this is the log file, or the log line, and this is the trace line. Var matches of type boolean, and an init function. So the init is going to take both lines, and yes. So what I want to keep are the last two traces before an error occurs. So let's do var previous trace equals array of trace and bar last was error. Or better yet, last printed. Last line printed. Yes, I want to do that. So, this function will say logline equals plogline traceline equal ptraceline. Let's do the trimming here. Put this, paste here. So it's no longer compared with, now it's called traceline. Let's rename it here. So now we can do trace line. Okay. Now we can create a trace. Trace.new and pass. First is the log line. Right. So this is the log line, not the trace line. So here is the log line, and then is ptrace. If not trace dot matches, then we'll do some stuff. Otherwise, we'll do some other stuff. So for now, I will comment this and comment this. So now I can focus on this stuff. So now I want to say matches equals yes, so this was supposed to be the log line substring to compare it. So I want to know if the trace line equals to trim. Okay, now I will make a function, call it print, and it's okay. I am making an override. I hope it doesn't complain. So let's add some coloring stuff. So let's say print rich, and we are going to print if matches, we are going to print rich, and we are going to print the trace line plus, let's make color equals, let's say yellow, and let's close color, and in here we can add the rest of what did not match, the part that we are ignoring. So we can say so I think we can storing here. Okay, trim is going to be equal to trace line. So let's put the reminder. Remainder is going to be equal remainder, not remainder, to logline substring starting on length so trim is the left part, remainder is the right part. Now we can choose print reminder in here. And let's make a function bar did print who equals false. So if it doesn't match, it is going to take let's delete all of this and let's go and let's rename this to trace history. So now I can use trace history -1, which will be the last one added, dot print trace history -2, actually -2 first, then -1, print, and then this trace.print. So did print will allow me to say if did print return, and will do nothing, and it will only print once, else will do something else, and then did print equal true, and this will make sure it will be only printed once. So in this case we are going to create a special line for printing the mismatch. So in this case we are going to say bar out of type string, let's say for e in, and let's use the trace line. And what I want to iterate are the characters, each character. So this to access both I need a range. So instead of iterating each character, I will iterate the index. So I will go with a range of the size. If trace line substring at the position index at the length 1, so this is only one character, if it equals the log line Then we are just going to add the character out plus equal and the character. And yes, of course, we also need to make the substring in the log line. What are you complaining about? Okay, it does not have a size, it has a length. That's correct. Else, that means okay, so let's say I just noticed something out. So one is going to be the trace and the other is going to be the log. And both are going to start with the line number. So we also need to store the line number in our trace. So let's say the line integer and say line equals the line, and finally add it to the constructor. Okay, now we can actually include the line in this print. So this is going to be out trace and also out log. If there is no match, we're going to make something similar, but we are going to add a color before. What? A color? A color? And the closing of the color. And we are going to add red for the log because we are deleting, and green for the trace because we are adding. So this will look like a git log, hopefully. So we are going to print reach first the log line and then the trace line. Let's see how that goes. Yes, and we have to add the trace to the trace history after this. And I think that with this we can remove the weighting, because we should not have so bad standout. So I think I can comment this. Let's see how that goes and run. Okay, we got a very good output with this. So the only way to improve this would be adding an empty line. Yes, and I also want to to add the rest, right? Why did this not have the line number? Oh, because this one matched. Okay. It does not have the color with the remainder. Did it not have a remainder? Oh, right. So this is shadowing. What else is shadowing? What else do I have? Attempt to write in ROM space. Okay, nothing else. So that's why it did not print that. And I also want to let's return to this. I want to include this. Before the trace, in the case of the match. And I want to also include these after each of the log traces. Actually, it does not go in log, in trace, only in log. Okay, that's awesome. So now that we have very significant information, we can find what was the last instructions and what is matching and what is not. So I think that I could say I could add a few more lines of prints. Where is it? Okay, here it is. So -3, -4, just to have some more context. And I want to have a new line. To have some more space to identify where stuff is starting and ending. Okay, awesome. So now that is an output. So this is the part that we are ignoring. This is the part that is not matching. This is memory. This is instruction. This is memory. This is the bytecode, and this is the instruction. So in this case, roll is failing, and because of that, we have a wrong processor value. So from now on, I plan to not be so talkative, because now I just want to fix stuff, and I will get tired of talking if I explain everything I make. Especially when I don't yet know what I will be doing, to be honest. So I think this is a huge improvement. So let's do something more. Let's add a mismatch count. Okay, mismatch count equal 0. Mismatch is 1 or 2 S's anyway. Mismatch count plus equal 1 if mismatch count bigger or equal 5. Have some stuff. We can stop the emulator. So I think I can do forward it and shine. Quit. And let's search. Oh, it's scene 3. Quit and shine. Get main loop. Quit. Okay. Exit code 0. So I can run. Hey, it did not stop. Why is that? Why is that? Okay, it's ignoring it. Why is it being ignored? It's not putting any error or any log. Okay, let's just put a breakpoint instead. Okay. So the point is there is no need to continue once you have a mismatch. So git status. Yes, we effectively no longer need this, so instead of commenting, I will just delete it. So we changed the tracing instructions, and that's all. Git push. It's carry. So row. Okay, we are not updating carry. Let's see the documentation. Nope. Let's see the documentation for roll. Carry is set to the content of the old 7-bit. Okay. Okay, but this is being set. Yeah, this is not correct. Yeah, this is missing an OR and the previous register value. And the same with memory. So bar odd value equals memory read address, and this odd value shifted, and this is OR odd value. Basically, we are always setting the bit flag because of this that we was doing. Okay, got breakpoint. Okay, move it a couple. Nope, it's actually getting the same result. So why did it not help? Let's try this. Storing the old value. This is gonna be the old value shifted. If flags value equals 0x85 breakpoint. Okay, we stop it exactly in the same point. So let's figure out. Okay, yes, that is 1, 2, 3, 4, 5, 6, 7, 8. So we are comparing the wrong bit. Probably because I was meant to compare it to value, not to the old value. So let's try it once more. And now it passed apparently. Okay, it did not pass. So what is odd value? 85. A decimal 85. Apparently the same number. That means carry flag is meant to be unset. Oh, I did something stupid. So let's say the register is register A. The value is 170 now. which is correctly the value 85 shifted. It's like this, 1 and 1 in the positions 1 and 3, and 70 is the positions 2 and 4. So what is it with the flags? So where is the flags register? Okay, the value is 175. And we see that the carry flag is set, and it should have not been set. Why is it? What is old value? It's 85. 85? Or because I am doing an OR and it should be an AND. Bitwise. Bitwise stupidity. Okay. This time that passed. Okay, I see we are missing something in this print. But it is just the format apparently. That's cool. So git status, git add. Yes. Git commit. Actually, before that, this was rotate left. Let's see, rotate right. Do we have the same mistake? Rotate right register. The value equals true if value and 1. 1, 1, 2, 3, 4, 5, 6, 7, 8. Put in the 9th bit. That's correct. And value is the value and 1. It seems correct. Okay, this one looks correct. Awesome. Wanted to confirm. Git commit. Fix carry flag on row instruction. Awesome. So now this one that is printing wrongly is for the indirect X, the trace. So indirect X should be printing Uh, it should be printing address is 200. It should be like this or like this. And we are missing an equal in here and another value like this in here, but I don't know exactly what is these other values because we have address value and what is the other one. Uh, oh, okay. It was the same as the instruction. Like this, maybe? Okay, now it's no longer matching. I did something very wrong. Mm, wait a second. Yes, I changed it in the wrong line. That's why. False alarm. I still did something wrong. What am I doing wrong? Okay, so this is not what I want. LDA 80 is not what I want. I just wanted the 80. Yeah, I am getting errors. What was it? It doesn't look wrong. What am I doing wrong? And why is it repeating LDA to start with? LDA is not added at this point. Don't disassemble. A number is required. Right. So I need to turn this into an integer. Okay. That looks kinda legit, except it is not a hex value. So this is not what I want. What I want is the content. Okay, I know. So what I have to do is converting this into a string argument, and then I can use this string. Okay. Something did not work as I expected. Oh, I see. It's 80 plus x. That is why it doesn't match. I see. So it's a very special case and I can consider it in here. So let's use this. Let's take this. This value. Bar address plus x. So we can read the memory directly. This is address, not add. Okay. That one passed. Now this is correctly reading address plus x, but this is reading incorrectly. So x is still 3 in here. This is supposed to be... we don't know what is on FF. Do we? Oh, it is loading 0 on x. So x is 0. So why address this did not match? I am probably completely wrong of what this means. Oh, 0303, is that right? 1096. Go to 1096. Yes, 0303. Okay, and what is address? Get operand address. Addressing mode. So maybe this is not right. So what should be this address? Okay, it did not stop. FF04. Okay, so let's take it easy in here. We still have no prints, but I can see the trace history. Here is the trace history. So in this case, address instruction is LDA with addressing mode 8. Hey, yes, doing fine. I have improved a little my login messages, so now I get a more clear idea of what is different. Let me show you. If I comment this and comment this, and if I run, I get a more clear idea of what is not matching. So this is how it works. I am running a NES ROM that is expected to give you some output, and I am comparing the output that I am writing to the output that I downloaded that is expected. So in here I have what is not matching. This is the original file that I am reading from this file. See, there is a lot of garbage in here. And I am comparing my output with this line and stopping when it doesn't match because there is something wrong in my CPU or in my prints, whatever it is. In this case, the error seems to be on my prints. Actually, it is not in the print because it is loading the wrong value on A, so the instruction is wrong. But I also see that the memory address is wrong, so it is wrongly assigning the address. Yep, I'm having fun with this shit. So this is a very interesting case. Seems like I thought that my printing was wrong, but I just realized that no, it is not wrong. I am reading the wrong memory. So this is why it's good to have some more lines. So I printed some previous lines and some more lines after the last error to have some more insight. So I don't need this because whatever the problem is, it is happening on this function for indirect X. Can Godot compile code that would run in Windows 3.1? I don't know. I think there is no C compiler for C++11 for Windows 3.1. If there is, actually I don't know what is the minimum C++ compiler right now. And I don't know if the drivers are also compatible, but if you can compile the engine, you can run it on Windows 3.1. Very unlikely, to be honest. What do you mean making tools for later? What tool would you expect on doing? Oh, I see. For that case, I think you would be needing to make your tooling using Visual Basic 6. So Visual Basic 6 is not even supported anymore, I think. But you can probably get and download it and create tools, and it has you can make Windows forms with it. No, I know there is no official dev kit, but if you are making yourself those restrictions, this is the best software, development software that you can put on a Windows 95 machine. I suppose you are okay with Windows 95. If you want to use Windows 3.1 or earlier, that I don't really know what else can you use. At least it is the oldest software development kit that I have used. I have used also Visual Fox Pro, and it is more or less of the same generation as Visual Basic, and it had like how is it called? You could make programs to run on a console that looks like DOS, but I don't really know. I don't remember anymore how to use it. Also, I am mentioning Visual Basic 6. There are versions before this 6. The lag says Visual Basic for Windows 3.1. Visual Basic 3. Okay, so this is tooling for Windows 3.1, right? This looks like Windows 3.1. Most Visual Basic 3 was the most popular version for Windows 3.x development. So here is your answer. This is the best tool. And it seems to work exactly like Visual Basic 6, just in an older OS, because the tools looks pretty much the same. The controls and the inspector and everything. You edit the contents of a window and put connect to events that happens on the controls, etc., etc. You manipulate bitmaps, etc. But I also have no idea about the color limits. Like what is the color space? Because for some reason there are not many colors in here. So I don't know if you can use the entire NES palette in this thing. You get what I mean? But yes, this is your best shot. Where are you? Aha. I posted it on Discord. Okay, so don't push yourself. Look, this even has the download links for Visual Basic 3, and you can search for Windows 3.1 and install it in a virtual machine and test it. Like install Oracle VirtualBox and install Windows 3.1 in a virtual machine and try it and play a little with it, so you don't have to assemble a computer to see if it works or not. And I suppose you eventually want to make it in the real hardware, but I don't know why I have the feeling that it will be easier to start with a virtual machine. So I am obviously doing something wrong with this. Let me see how it works in the example in Rust. So let's see, where is CPU? Indirect X. It is doing the base. Add wrapping. Okay, so it is not modulos. Let's try this. If pointer bigger than this, pointer minus equal OX 100. And the same for pointer 1. Okay, so one matched, the other didn't. And why is it that doesn't match? So I am getting a pointer that is base, which is written directly, and adding X value. This is the same here. Getting base address and adding X and wrapping. Low and high. I forgot to delete this part. Okay. That is not quite right. So why 180? X is 81. So it is FF plus 81. is 180 in hex. Okay, I kind of see the issue, and it seems to be only on the print. Because for indirect X, this one, the address plus I need to do the same treatment. How about now? Okay, that's nice. So for this case, we are just not printing some information for the bit command. So we have some information in here. Maybe if we just add bit, that's enough. Okay, bit is still not printing, and hora is also not printing, and is also not printing. Okay, so this is the wrong case, because this is for registers. So this is absolute. Okay, here is the case. Bit, hora, see you later. what I am using for music, I am using the old and beloved YouTube. I should search it, search it for something that is royalty free to avoid issues later with copyright. Okay, what do we have now? Okay, more conditions, more cases. So we also want to check and EOR. Stupid. I need to make this bigger. ADC. What else? What else? CMP. Okay, what else? SBC. What else? Let's move on. TPX. So let's say substring, and I want from 0 the first 2 in, and we can put in here LD, ST, and TP. So this will work for CPX, for CPY. Let's make this parenthesis. Okay. LSR. ASL. Test. Let's run again. We have roar and roll. Let's make some examples. Roar, roll, ink. Okay, looks like we are getting to the end. Decrease, decrease, decrease. And now this is unrelated. This is related to Y, to indirect Y. Okay, problems with indirect Y, but it's just the printing. Actually, this one loaded wrongly. It was supposed to load A3, but loaded 00. So let's commit what we fixed up until now. What has changed? We fixed indirect X and added printing. This is all on the prints side. Git add part. This is the actual CPU. Oop. Yes. Fix indirect X addressing mode. Now I need to fix the indirect Y addressing mode. So first of all, let's change the print to match. So this indirect Y, this one. So this one should not have the at, instead have an equal. This one, wait a second, this should be 4 characters. And then have an at in here, and then another address of 4. So I assume that this first part is similar to what we did with indirect X, but for indirect Y. So address plus Y, indirect Y works differently. This one that didn't match, first it was FFFF. So let me remind myself how does indirect Y work. So it reads the base value and the next one. So let's take this, low and high. Actually, I will fix this. I will remove this. Is base use ever again? No. Okay. Base plus equal 1 if base bigger or equal, no, sorry, bigger than OXFF. Base minus equal 100. And then use base again. And let's remove a couple of semicolons. And indirect is having the same issue here. Okay, so let's call this base. And this one is going to be base. And copy this. So we have low and high now. This is supposed to be oh, I have not yet even added the Y. Y was 34. Okay, I see. So 97 and 98 are both FF. That is what is printing in here. So what is printing first is this base. The ref base, and it is the first argument is the ref base. Okay. So let's see. Okay. We're getting there. We are failing by one value on both the print and the calcul. And why is that? Base is 97, then 90x, and it is loading FFFF, and then it is supposed to be adding 34. I see. So let's do this. If the ref is bigger than this, the ref minus equal $10,000. Okay, it worked. Okay, this one is dumb. This is just... Okay, let's make a commit for print for fixing the index Y. Fixing the Y. This one is very easy. We just need to print correctly the address. It's 0 or 4. Okay. Okay, we're already on the 3000. That's great. So we have some trouble on jump. And some trouble on LDA with absolute Y. Okay, this absolute Y is dumb. So let's first fix this print for absolute Y. because seems to be the easier one. So this is 4 bytes. And this one is not matching. I see why. It's similar issues in the addressing mode. So we have to fix absolute Y and absolute X. So same issue here. If address bigger than this, address minus equal, and same for 0, no wait, for absolute Y. And this one is similar, but it's 2 less F's and 2 less zeros. Okay, I think that should be all. So, jump, jump, and now this one is taking one more instruction than one more byte than expected. That's a big one. So the instruction is 56. Okay, so let's first commit these fixes. More fixes for addressing mode. Improvement to trace logger. It's actually fixes, I guess. Okay, clean. And this was memory. Okay, I can ignore this for now. So we are on line 4000 now. That's awesome. Why is the mouse moving alone? That's weird. So 56. LSR. It should be taking. Oh no, it doesn't take 5 bytes. It takes 2 bytes for 0 page X. That was wide. Okay. So jump. This is just printing error. LDI. LDI. So this is just printing format for indirect X. No, sorry, absolute X. Yeah, so this is supposed to be 4 bytes. What else? What else? It's all more of the same. Okay. We are on this instruction that is failing. Instructions says to be 4. And the line is oh my god, 5000. We're on line 5003. That's a big advance. $5,003. So the instructions says to be 28 in here, PLP, but we are reading a 4. Why is that? Okay, this line. It's a no operation, but it's a different no operation. Is this the first asterisk? If I search asterisk, this is exactly the first one. So these instructions seems to not exist. So let's see if that is what we was warned about in this. If everything is okay, the first mismatch should look like this. PLP, yes, 28. And yes, this is the line that is mismatching. Is exactly the same memory address. Okay, awesome. That means we are online. So let's just fix the jump printing. And that should be all, famous last word. So let's see, why is jump failing print? What is jump mean to be printing? Say MP. Let me check something. Jump. Is absolute or indirect? So jump for indirect is not printing nice, but AMP. Okay, it works fine for absolute. Oh, it's actually not printing anything for absolute. So is it an issue on indirect? So let's try to search some other usage. Maybe it should be all indirect that should be printed like that. Indirect. So instead of equal, why is it let's try this. Let's comment this line and try to change it and see if it breaks some other place. So now it should be choose an equal with 4. And what is this value? Is it the new program counter? Yeah, no, it is the current program counter. No, this is not the case. TV7E BCDE. Okay, it's the new program counter that is going to have. So this is program counter plus instruction dot size, maybe like this. Okay, it didn't like it. It liked it for the 2 cases that I mentioned earlier, but not for this one. TV5. I want to improve a little more the print. Are last printed. Okay, this will be a couple more prints after errors. So what is being stored is the new program counter. Okay. So basically this is value. Okay. If I print value with 4, it does not match. And why is that? Wait, is it value or is it address? None of them. So we probably need to do something like this. Let's see how does indirect work. It reads a value. Absolute or indirect, and this is how indirect works. So it has this special treatment. So I will copy this, go back here. So I will address, getting from program counter. Why is this an error? Address already exists. I suppose I can change it. Okay, let's try it. Still not working. So let's try to put a breakpoint. Maybe it's +1. Okay, it was +1. Okay, and this last printed. Let's make it -5 so it doesn't print the first 2 lines. Okay, awesome, no diff. This is ready to be commit. More fixes to trace logger. Okay, awesome. So we are finally ready to continue with the tutorial. Um, so what does it say? Everything that our emulator has produced should exactly match the golden standard up to line 0x0011. If anything is off before the line, we have a mistake on our CPU implementation and needs to be fixed. But that doesn't explain why our program got terminated. Why didn't we get perfect match after this line? The program has failed at this line. It looks like our CPU doesn't know how to interpret opcode 0x04. Here is the bad news. There are about 110 unofficial CPU instructions. Most of the real NES games use them a lot. For us to move on, we will need to implement them all. The specs can be found here. So we have this txt of undocumented opcodes. I wonder why the mouse moves alone. Um, this is not very welcoming. Remember how to draw a node? The test room should drive your progress. In the end, the CPU should support 256 instructions. Considering that 1 byte is for the operation code, we have exhausted all possible values. Finally, the first mismatch should happen on the line DB8B, almost at the very end of the NES test log file. That's a good sign. 4015 is a memory map for the APU register which haven't been implemented yet. Okay. So, I think this is a good moment to stop the streaming. We have a very solid product right now, and we're ready to start implementing new instructions, and we have the list of instructions. We are going to have to pick where to read them from. This one looks maybe... No, it's not easier to read. I prefer this txt file, to be honest. Let's see another version. Not really. This one. Nope. This one. No, I don't quite like it. Honestly, I think I prefer the txt file. Anyway. Thank you very much for watching. We have done quite a lot of progress, and see you next time.